Hello, we have we are now looking at integration. So we have the question with us here. So integration is actually the opposite of or the reverse of differentiation. So remember, differentiation, we are previously multiplying to find the derivative of any given function. We are actually multiplying the coefficient by the power, and then we reduce the power by subtracting -1. Okay, then here it is now the opposite. So this is called antiderivative or integral. So antiderivative, that is integration, is actually in two parts, that is indefinite and also definite. So we're going to look at definite later on. For today, this is what we call indefinite, and it's a part that comes in paper 1. I think you are all familiar with it. So in this case, I have the question with me. So let's get into it. So we have evaluate. This is integral. So this is integral, and then open bracket x to the power 3 plus 2x plus 3 close bracket dx. So the first thing that we're going to do is restart our integral first. So we have the integral, then we have x first to the power 3 plus 2x plus 3. So that's what we have. So what is the opposite? Under differentiation, the powers were reducing by subtracting -1. So what is the opposite of subtracting? Of 1. That is now adding. So here in this case, powers increases. Okay, powers increases by adding 1. Okay, so that is the opposite we're talking about. So now in this case, we have this one. So I'm going to find the difference, the integration of this one. I'm going to integrate this one. So in this case, we have the formula. So the formula is, if you have any function given, the integral of ax raised to the power n, okay? If you have any function like this, then we have dx. So this can be integrated by ax, okay? This is the formula. So in this case, what does it mean? Simply mean, if you have any function given, in this case, what you need to do is you need to increase the power by adding 1, and then you divide the same power. Okay, you get the same power, you divide it into the same. So in this case, we have this with us. So we have x. What we're going to do is we just say equals, we have x, it's raised to the power 3. So what I'm going to do is, this is that raised to the power 3. It simply means we are going to add this 3, we increase it by adding 1. And then what does it simply mean? It simply means we divide the same power here, we bring it down here, the same power, we have 3 plus 1. Here no need of multiplying. Then we continue, we have 2x. What is the power of x? It's 1. So it's 1 plus 1. Okay. We divide the same power here. Okay. So we have 1 plus 1. Okay. Remember, under differentiation, a constant number becomes a 0. But in this case, since we are doing the reverse of differentiation, it simply means before this 3 was integrated, it simply means before this 3 was differentiated, okay, before it was differentiated, it simply means it had x. Okay, so it simply means, since we are taking it the reverse of differentiation, if we take it into differentiation way, meaning before it was differentiated, it was 3x. You agree with me that if we differentiate this 3x, it simply means it will be 1 minus 1, like that, of which it will be 3x. It will be 3x raised to the power 0, of which nothing to the power 0 is 1. So now the opposite the reverse of these 3, meaning in this case the reverse of 3, it will be 3x. What does it mean? Simply mean any constant number under differentiation, in this case, sorry, I beg my pardon, under integration, it will always gain x, any constant number. So any constant number, mark that, any constant number under integration, it will gain x. Since we are taking it back, we are doing the antiderivative, that is now the opposite of integration, differentiation. So we make any constant number gain the variable. In that case, or in this case, it is 3. So 3 has gained the x there. So we continue. So we have x in 3 plus 1, that is 4, and then over 4, plus 2, we have 2x, 1 plus 1, that is 2, over 1 plus 1, that is 2. So you can see these are the same powers that we have brought down as the common denominators. Then plus 3x. From there, in this case, whenever necessary, make sure that you reduce the denominators into numerators. You reduce by dividing denominators into numerators whenever possible. But in this case, you don't have anything to reduce with. Never should you make a mistake by dividing or reducing this denominator with the power. We reduce the denominator if there's any coefficient here. Like in this case, we have 2. So 2 can be divided into 2. Okay? You remain with x to the power 2. So this one, we'll write it the way it is. That is x raised to the power 4. And then divided by 4. Here we have remained with x raised to the power 2 only. So we have x raised to the power 2. Then plus 3x. So since this is the antiderivative or the indefinite integral, so what you do is you add, you say plus c. C is the constant. Since in this case we don't have any other means of finding that c, so that c is always shown there like constant. So simply c means constant. So it's our answer ends here. Okay, so remember, the constant number gains the variable since it is the reverse of integration, differentiation.